Okay. Welcome to the fourth episode of Learning Live with AWS and HashiCorp. I'm here today with my wonderful streaming partner, Jenna.
Hi.
It's
Good to be
like,
here
it's like,
again.
do we do introductions every time? And I'm Cole, and obviously our names are displayed right below us. So far, Jenna, where have we come from? I feel like we're kind of at a halfway mark, right?
Yeah. So we've spent 3 episodes now getting our microservices set up using Amazon ECS. And we've been doing that using Terraform. So we've been learning about Terraform as well at the same time. And I'm sure you're wondering where those past episodes are, and we'll drop a link in the chat here in just a moment. Because we do have a playlist on YouTube of those for you to check out. And then, yeah, we're about at the halfway point, and today we're going to kind of jump into the next section of stuff, next chunk of stuff. And I think one thing I'm going to, I think let's talk about this now, is let me step back. So we have been having different lengths of streams. We've been kind of experimenting with the length there and how we chunk up what we do. And so today we're actually going to work on time boxing this to an hour and a half, because we know that most of you probably don't have 3 hours out of your workday to spend with us, even though we would love that. And so just kind of keep that in mind. We're going to get partway through what we're working on today, and then we'll be back in 2 weeks to pick up where we left off. And again, as always, we'll share the code at the end of today's session so that you can start playing around with it and extend it if you'd like to, or wait for us to get back into it.
Yeah, that sounds good, because otherwise extending it when we start competing with the runtime of Lord of the Rings, that's when you know. All right.
Yeah.
That's when you know something's up.
Yep.
Yeah. So as Jenna said, we have built out what we've been doing on Amazon ECS. We've been doing it in Terraform. We've been heading towards this microservices architecture, which we completed sort of the first version here, right? And in terms of how it is, I want to get your thoughts on this as well, Jenna,
Yeah.
but it's pretty good for what I would say a lot of people want to go and do, right? We have a path towards scalability with it. We have fault tolerance built into it. There's a lot of things built into it, but what are your thoughts on what we have so far? And maybe if you could, perhaps you could pull up that architecture diagram and I could show it up on the
Yeah.
on the screen.
Are you talking about the GitHub architecture, the one we have on our repo?
Yeah, the cloud craft thingy. I'll just tell me when you're good.
Let me do that.
There we go. But we've been heading towards it, and it's always just this thing that everyone's going to have to face, right? Which is it enough, or do we need more? And if so, why? Right? And what are your thoughts on how we have this structured right now? And if you were building something, what it would look like going forward, a year from now, a couple years from now?
Yeah. So I think one thing that when we hear the word microservices, some of us bristle at that, because you're not starting out just to build microservices. There's a reason why you're doing it. Because there's some pros and cons to doing it, just like there is with any other technical decision, architectural decision that you're making. And so as you can see here with our the architecture that we have shown here, we only have 2 services that we've created, 2 functional services, and then that ECS client service that kind of fronts the 2 of those. And in a real world setup, you're probably not going to do this for 2 services, because there's a lot of overhead to it. But as soon as you have to scale this to many different services, like hundreds of services, or you need to be able to scale within each of those microservices individually and differently between the two of them. For instance, our fruits service needs to have more instances than the vegetable service because it just happens to have more traffic. As soon as we get into that situation, then that's where this can be a little bit more of a better choice for us. And so I think as we've been going through that, that's definitely been on the back of my mind. And I want to make sure that like all of you at home kind of understand that, while it's cool to learn some of this stuff and the architecture behind it and why we make some of these choices, it's also important to understand how to make those decisions. So
that is very important, right? Because like clicking a button takes like 5 seconds, but understanding why you clicked the button,
yes,
that is key, right? And I just got to laugh. I got to highlight this comment we got from Alex here. Is it just me, or is there something magical about saying service mesh?
Yes, exactly. Hi, Alex. Okay, so also hello to all of you at home. Thank you for joining us today. Before we get too far into this, so Cole, where are you based out of today?
I am based out of Pasadena, so LA, just
LA,
basically
okay.
LA. Yeah.
And I'm in snowy Minnesota today. Today it's snowing.
Snowy.
So where are all of you from? Where are you joining us from? Maybe in the chat if you can. Just drop your city or state or country. It's always fun to see like where people are joining in from and who you are. So thank you for joining.
Yeah, absolutely. Yeah, for sure. So as people chime in and give us, there's something I do want to note. If you're seeing some comments and we're responding to some things that you don't see, it's because we are actually streaming to LinkedIn, to YouTube, and Twitch, all as one, right? So that's and also if there's some delay between us and response, it's because from where we're streaming, there is like a slight, I think it's like 30-second, a little bit of a delay between what we say and it actually reaching the interwebs. But yeah, so we got a global audience all over the place. Athens, France, Texas, Canada, sunny Scotland. Wonderful, wonderful, wonderful. Okay, so as people chime in, I do want to highlight Alex's comment again, because this here, I really feel was my entire experience when I came into this, trying to figure out what the heck service mesh is, because much like other buzz terms in our industry, we can get really carried away with it and they become, a panacea for all things, which we know is never true. So today, before we hopped in, we wanted to give some conceptual overview of what service mesh is going to do for you and what, and how it works in general. And this is kind of the scary part. This is where I would always get lost, because I go into stuff and the impression of service mesh, you can kind of like, it's easier to give it in a nutshell if you don't know it than when you do know it, because the more you learn about it, the more you're like, I don't know what is going on here. So what is your impression of service mesh as things stand, Jenna?
Yeah. So for me, service mesh is actually a new concept. So as Cole and I have been kind of planning out these episodes, I've been learning alongside of our planning process. And so for me, it feels like it's very much like this kind of a brain that like helps us not only route traffic internally within our microservices, like to make sure that they can communicate to and from each other, but also and I think we'll probably get into this as we get deeper in, is which services get to talk to which other services in our service mesh.
Absolutely. Yeah, I mean, that's it, right? And you ask different people, unless you've gone into deeply studying and working with it, you're going to get kind of a different thing. I literally thought I was going to throw a mesh on something. Fish mesh, just like, all right, we got everything roped together. The way it works is a little bit different though. Now, we try to avoid slides, but we're going to do some slides here because quite frankly, it kind of needs it. So I am going to put up some slides here, much to, well, I mean, I think they're okay. We'll see. We'll see what y'all think. Let me go ahead and share my screen here. So we're gonna throw this one on. And can we see the thing?
Yes.
Can you see it, Jenna? Sweet.
Yeah, we can see it. Is it possible to get rid of the slides on the left-hand side there? Just to make it a little bigger?
Aha. Yes, it
Yeah.
is.
Excellent.
Nice. Now I think I pressed down to go, right? So obviously we're going to step into the service mesh console portion of our series. And right now we aren't using it like we've said. But instead, each time that we want to add a service, there's some things we got to set up to get them all connected, right? Load balancers, tweaking config, security groups opened up. And, if you're actually writing the application instead of using a fake service like we're doing, you're probably going to have to change some stuff there. So Jenna, what are some of the pain points you've seen so far and you predict that will occur as we scale, both from an operator, but then also from your software developer hat? Like, what do you see here?
Yeah. Just looking at, you're talking about like the code that we've written to date, right?
Mm-hmm. Yeah. And growing it forward.
Yeah. So I think one thing that, it's one thing if I'm a solo developer, and writing a couple services, that seems fine to me, but the amount of code that I have to create. But as soon as we've added more people to our team and we've added more services, our code base kind of like explodes a little bit. And that's in places like, I think, where am I thinking? The services that we have to set up, both like the within our cluster, we have now I can't even remember what the pieces are. So we'll look at this in a couple days. But yeah, so like in our cluster, the load balancers, the services, and I think are we doing a task definition? Yeah, for each service we have to do a task definition too. So for me, it's it just is like as our code base grows, or as our services and our needs grow for services, and to be able to scale, all the other stuff has to scale with it, along with potentially our team of developers that are working on it. And so that's, again, like that's one of those things that's been in the back of my mind as we've been going through this.
Yeah, that is exactly, you just nailed it right on the head, right? Which is that if we ask someone who's created a different an architecture, similar as it may be, their answer to what they have to do to get them connected and more things added is going to be a little bit different, right? So that is part of the problem. What do? You got to keep a list of all the different manual work you got to set up and do, and it's going to change based on what you're building and who you've got on your team. But before we get too carried away in the terminology and concepts, I want to make sure we know the situation that we're addressing, and that is this world of microservices where we have, in essence, a bunch of smaller services working and communicating with each other. And even though this world looks beautiful, I mean, I guess this picture's not that great, but it's full of, as we've talked about, various pain points. And what Service Mesh is trying to do is it's trying to impose some order and standards on how we go about doing this for our own good. And this is probably a good place for a little bit more discussion, both from like audience perspective and just from yourself, Jenna. In the past, when you've gone to say add another service, what's been the like hammer that you've gone for the nail, like the simplest thing that you've done, or just generally what you would do in the past?
Do you mean like with what we've been doing here, or just in general?
Well, just in the past, like let's say you had like a multi-tier application and you needed like a mail service added. What would generally be your kind of flow for that?
Yeah, I mean the flow, after like defining what the API should look like and what it's going to do, and whether it's one or multiple services that we need to build, it's really going in there for me. I'm generally going from one end down the stack, trying to figure out like I need to have this front end API. I need to have it connected to whether it's a function or it's a service running in a container, or it's something else, a database. and then figuring out how that functionality connects to all the other things. So again, like we're getting every time I talk, I'm getting back to all this communication that has to happen and the coordination of things.
Yeah. So, and similarly for myself, it's, and I love asking Jenna about these things because we can hear the software engineer roots come out, which is always an interesting perspective when you go into ops because it's from the different direction. But in general, what we wind up with, I feel like the summary of it is, if you don't want to have to touch it manually, is you get more and more automation, right? And so when asked this question, what is the alternative to service mesh? I'm sure there's others, but the most common approach you're going to hear is just more home-baked automation, right? When you stand up a service, you got to write more scripts, you've got to put in more GitHub actions or, code pipeline actions, whatever it is. And you wind up doing a lot of stuff, right? To stand up new services, to lock down connections between services, to deal with limiting permissions, and perhaps you want to even go more fine grained and say that for our particular API, you only want parts of it accessible to some and not others, right?
Yeah.
Does all sound like...
Yeah, I just was going to say, like, we haven't even touched on like the continuous integration delivery type of stuff here. And again, like that's a whole nother topic. And we won't get to it today for sure. Maybe on our last episode, we'll touch on some of that stuff, but that's just another thing that kind of that has to play into all this too, as we have to manage the communication between different services and the access to different pieces of functionality, and also the maintenance and delivery of it as well.
Yeah. There's a lot. Every time you think something's done, you realize that you're in a stack of dominoes and there's more that are coming your way, right? And the other thing is too, for me, is you'll wind up using some common practices and tooling. It's almost inevitable that you will, right? But you'll also kind of wind up with sort of a snowflake of a process that's coupled to your infrastructure. For me at least, and maybe I just am terrible at automation, but in any past infrastructure that I've set up, I could not take what I've done there and drag and drop it perfectly copied onto another one because, everything is a little bit different. So, while we talk through this for you, the audience, if you're not on service mesh, what problems, or maybe the biggest problems, are you having when it comes to adding new services to your existing architecture, right? And Jen, if you have any crazy stories of your own, I'm sure everyone would love to hear those.
Not that I can really share, but yes.
Yeah.
I would love to hear your stories if you have them.
Yeah, maybe just for time, maybe I'll throw some in, but yeah, it's never done. That's a great comment. It really isn't. So then what is a service mesh then? We know what it's trying to do here is this. I know. It's trying to make less work for getting this done. It's trying to impose standards. And I'm going to just go and give you a spoiler. My artwork's not going to get much better than this. So bear with me here. But instead of diving right into the technical definitions and concepts, which are filled with dragons, right? I'd like to begin with an analogy. I say this because if you've begun any type of implementation before, there's a lot of information to digest. So we're going to just set up this scenario here. So let's say we've got 3 people, myself, Jenna, and Blake. And I'm picking Blake because Blake helped me out a couple days ago with answering some questions around Consul. We all send and receive literal postcards to each other. And each time we send one, we got to hand deliver it. Like Jenna's got to come to me. I got to go to her. She's got to go to Blake, and so on. Now, in this analogy, the people are the services. The postcards are the messages that we're sending between services. But there's a third thing in here too, and that's the delivery itself. So when Jenna delivers something to Blake, it's going to be a very different experience than when she delivers it to me. Where I live, maybe the mailbox is located at a different part of the house. Maybe there's like postcard thieves that like watch my roads. I don't know. But maybe Blake lives on the safest hill ever, and therefore giving the postcard to him is very simple. The point is that our little postcard group here faces differences based on who we want to send a card to. And as you might guess, as soon as we add more people, there's more overhead, right? This is going to grow. We're all going to have to learn new ways to deliver these postcards to someone every time someone new is added. So hopefully this analogy is lining up with how things are for the most part. How are you feeling about it right now, Jenna?
I mean, this doesn't look too complicated at the moment.
Yeah.
I assume I mean, I haven't seen these slides, but I assume your next slide is going to like.
Oh yeah, it's going to be beautiful right now. Well, what if instead of all of us going to each other directly, we use delivery people? Okay, now suddenly things have gotten a lot easier for all of us, right? Now the process, yeah, right, yeah. So now the process Jenna uses to send a postcard to me is exactly the same as she uses it to send to Blake, right? She doesn't have to learn any roads, directions, or deal with postcard thieves. She just makes it, hands it to the delivery person, and she's done, right? The delivery person, through snow, rain, and whatever, makes that delivery happen and gives it to the other delivery person. And that's sort of the other side here as my cat decides to interrupt. The other side of the... Go ahead.
No, I was wondering if that was the cat.
Yeah, it is. Okay, Josie, you're going to have to go do something else. But the other side of this is that it makes receiving the postcard the same for everyone, because maybe without the delivery person, sometimes maybe when Jenna would come deliver the postcard, she would just like frisbee it across the yard and I'd have to go like find it, right? Well, no more of that, right? So there's some benefits, there's more benefits to switching to the system, but hopefully this right here is kind of giving you sort of a hint as to where we're going, right? We have these delivery people that are doing it on our behalf. What are your thoughts on this so far, Jenna?
I like that someone else is doing it for us, and I like that it is uniform, so that I don't have to learn how to do it every single time or do it differently every single time.
Yeah, totally, right? So, where was I here? So, sorry, my cat has completely hijacked my train of thought. As we add more people to our group here, this is going to be another big benefit that we get, is the standards aren't going to change. The communication between them, like unlike before where we'd have to learn a new way to say we add Rosemary and Darko here, right? If we add them, Jenna's not going to have to learn the roads to get to them. She's not going to have to learn where their mailbox is or anything like that. It's still going to be the same thing. We give it to a delivery person. The delivery person passes it on to someone else, right? So standards are set in place. Now, if you're following along with the analogy, then you probably have kind of deduced that the people here are the services, and you would be right. And the delivery people have something to do with the service mesh, and you're also right. But let's continue on now, because there's another benefit of also going through the delivery people. And let's assume that all of the delivery people are led by a delivery manager. Oh, okay. Well, through this delivery manager, we can do and learn all sorts of things, right? We can set up common standards like, hey, every postcard should be kept in a lockbox in transit. Or, hey, if you deliver a postcard to Cole, make sure you go in through the back door. Or, hey, maybe we just cut Cole off from sending messages to some people. And we can do that from all one central place rather than us all having to communicate a bunch of one-off rules to each other, right? Well, my friends, if you understand this analogy, then you understand service mesh. This is what it is at its heart. So I'm going to do a really lame magic trick here, and I'm going to swap out all the analogy pieces here with what's actually happening. All right. So instead of people, we have the services, which we know. Instead of delivery people, we have sidecar proxies and the Consul agent. And instead of the delivery manager, we have the Consul servers. Now, this is for Consul, but this analogy holds true for most service meshes. So how are you feeling about that analogy at the moment, Jenna?
Well, I was just thinking that you always have
Are
you still there?
My internet just did a hiccup.
All right.
Apologies. I
was saying your analogies are always really spot on, and this is no different. Like this, starting off by how you described it, that was really helpful for me, and now I kind of understand where we're going with this and how this should work.
Perfect. And apologies to the audience for both my internet and cat hiccups, but I guess those kind of go hand in hand, right? So yeah, so we've got this. Hopefully, with this analogy, the real terms make a bit more sense. Instead of our services communicating with each other directly, they all use a proxy. All traffic goes out through the proxy and comes in through another proxy. And since such is the case, a lot of control and observability comes to us, right? Because at any given time, we can see what's going on in that proxy. We can lock down connections between certain ones. We can detect errors. I mean, there's a lot that's possible, and it's all standardized. We don't have to set something up different every single time. Now, this analogy does kind of fall apart when I say add auto scaling to services, because there's not really a case where there's going to be more than one Cole or Jenna, but so we'll kind of step away from the analogy now. But one of the other benefits we get from the system is load balancing without a load balancer. So what I mean by that is when something comes in and we say we need to reach a service, a Cole service for this example, well, the delivery person of the proxy can then go and select on our behalf instead of having to set up a load balance for every time. So it's just something free that we get. So that's something that we'll add. And the other thing is service discovery. Every time we add something new, well, it only takes like the work that we have to do to make it so that all of our other applications know about this new service is also greatly reduced. Okay, so that is Service Mesh. Hopefully that all makes sense. This is mainly what you need to know to operate. Obviously, when you dive beneath the surface, there is a lot more here. But before we move on to the components, because there are a couple components we need to talk about, I just wanted to ask Jenna, so with that analogy set in place, what are your thoughts on Service Mesh now? Like, how is this compared to what you thought it was going to be?
It's pretty close to what I thought. I forgot about the yellow box that you have there. I think you called that the service discovery. I think that's going to be an interesting piece for me, just my own learning as we get into this a little bit more.
Cool. Okay. So the next thing that we need to talk about are just some components of Consul. So the core components, funny enough, there's actually really only one, right? And that's the Consul agent. I mean, really, you can think of this as the Consul command line interface in the sense of how you'll work with it as an operator. From an ops perspective, you're just going to download the CLI, put it on your server, VM, container, whatever, and you're either going to run it in server mode or client mode. It conveniently serves both. So that's really nice instead of having to have two. Now, there is a second component here, and that is the Envoy proxy that's going to be used in combination with the Consul agent. But from an ops perspective, it's kind of going to be hidden from you. I mean, you will, if you're going to debug, you'll have to go into it some. But for the most part, you're going to operate through Consul, and it's going to do what you need through Envoy. Now, Envoy is a different topic for a different time, but just know that it is an open source proxy. But in general, there's just one tool you're going to be dealing with, and that is Consul itself. So in terms of what you need to know to keep doing stuff, that is primarily it. Now, there are some two interest topics here, and I will leave this up. But the two interest topics, Jenna, are the Raft consensus protocol that we talked about and we discussed, and then the gossip protocol. What were your thoughts when you went through those?
Yeah. So for the gossip protocol, I think like the big thing to me was again, it comes back to the communication, and I don't know, are we ready to share that Consul architecture diagram that shows some of that?
Oh yeah. We can. I was gonna, since that had all the ports, I was gonna do the ports sort of towards the tail end, just because.
Okay, we can wait on that. Right. I won't reveal all the stuff, but again, like that piece, I think was really interesting to me. Just the approach to the communication through these different ports between the different services and across data centers. And then the other piece, and this is a piece that I don't know as much about, but the raft peering concept, that's completely new to me. At least the name of it was new to me. But yeah, it's so new. That piece is so new that I don't have a lot of thoughts on it. But It's interesting. It'll be interesting just to kind of see how that works as we get into the architecture of it.
Yeah, for sure, for sure. And so I'm going to kind of we can dive deep, and if the audience is interested, we can go into them. But the analogy that I have personally started drawing with the Raft consensus algorithm, the protocol, and the gossip protocol is to kind of like C groups and namespaces for Docker containers. You could probably use Docker containers for years without knowing a thing about those, and you would be fine. Knowing them absolutely will help. It'll give you a lot more insight in how to architect. They aren't necessarily requisite to working with it on a day-to-day basis. So because of that, I kind of wanted to keep the dive into it light, unless we get more interest. And I know that Jenna has a survey she'll bring up, and if that's something you want to see, I'm sure we'll both have more than happy to go into it. But what you do need to know is that the Raft consensus algorithm is one of the underlying concepts that Consul uses to make servers. So these folks right here elect a single leader that serves as, well, the leader. The rest are just followers. And all major transactions will be verified by that leader. And the Raft consensus algorithm is what's used to make these servers elect a leader and to deal with a case where a leader might go down and we have to elect a new one. So that's mainly what you need to know for there. The second of these two is the gossip protocol. And this is just how all of these agents talk with each other. So hopefully you can see my mouse here, but and without the gossip protocol, we'd probably do something where all of them go to the server and get their information. But with the gossip protocol, it's exactly what it sounds like. They just pick two at random and then sync up with each other and be like, hey, what's up? And then after they're done, they pick another two and they keep doing it until they all know. One of our engineers did a talk at HashiCorp and she gave a great analogy. It was that if you drop something, so maybe like break a glass, everyone around you has to say that the glass is broken until everyone in the entire room knows. Well, that's practically how the gossip protocol works. It spreads information that way. And it's because one of the roles of a service mesh is a lot of communication. So we need efficient channels and methods to make that communication happen. Okay, so that is all on those.
I like that name. I hadn't really thought of it that way, but the name makes a lot of sense now.
Yeah. And Mitch Connors actually just dropped a link here that I'm going to highlight here. This is an excellent link to go to if you want to understand Raft. It's an incredible animation that will go through how leader election works, what's going on behind the scenes. And so if you're interested in that, I highly recommend it. Okay. So that takes us on to our ports and configuration. Jenna, can I get you to pull up that doc with all those port things on it, just so I can take my screen off here?
1 second. Yes.
Yeah, there we go. So I'm going to just throw this on screen. So what you will need to know, though, as an operator, because so far a lot of it has just been for our own help, right? It's been here for you to understand what's going on so that the buttons you're clicking make sense. As an operator, the one thing you need to know, because communication is such a big part of what you're doing in Consul, is you got to have a lot of ports open. You have a lot of different firewall rules, a lot of different protocols to make sure that stuff is there. So question, Jenna, this is what would you prefer? We've been talking for a bit. What we can do is kind of give an overview here, or we could also just wait till we get to the actual part where we're coding in the ports. What do you think?
I think we can get into it. Okay, like that, cool. Like get into the code and stuff.
Yeah.
I think we've talked a lot about the communication already, so it's not going to be a surprise when we get there.
Yeah, and we can just come back and reference this diagram.
Yep. I'll leave this up too.
Yeah. The only other thing I'll say is that Consul has many faces. It does many things. I would say one of the things that I found a little interesting was understanding that the service catalog is different from the service mesh, which is different from our key value store. And when you pick it up, you may be using all of them. You may not. You may just be using one aspect. But that's just something to keep in mind. For our purposes, it is going to be the service mesh. Okay, well, that brings us to where the code part. So I've talked and blabbed more than enough, and my cat Josie has also made her usual debut. So it's probably time to move on. Okay, so Jenna, I know that you've done some stuff in the background before we started.
Yeah. So I took our code from the last show that we did, and I've already done my Terraform apply because we kind of wanted to save a little bit of time. So we already have, and I can even show it to you here in the console. We already have our 3 services set up and running in our cluster. So we are ready to start pulling in the console stuff.
Nice, nice. Yeah. So for those of you who do want to follow along, I'm going to just put up a banner here with the GitHub code. And to start with us, all you got to do is pull it down, follow the instructions, and you'll be good to go. Yeah. So what we're going to be doing is, because we are trying to do this all up from nothing, skip not many steps. This time around, we're going to be setting up the console servers. So those little pink cubes that I had up there, the brain. And Jenna, you were dead on, because you mentioned like you thought there's some sort of brain involved. That is what we're going to be making. And so the way we're going to do this is we're going to just set up some normal EC2 instances that are going to serve as the brain. So how about we open up that EC2 file, which it looks like you've already got open.
Yeah.
Nice. And we are going to make some new instances here. We're going to make some console server instances. So why don't we begin with a new resource, and we will just give it the secondary label of console server.
Just making sure my Terraform VS Code plugin is working, and it looks like it is.
Nice. Nice, nice, nice.
So I have my instance.
Cool. Now you had an idea when we talked in terms of like using this sort of as our like index of all the work we're going to do today, right?
Yeah. So okay. So that was one thing that we talked about doing a little bit differently here is instead of doing one piece in this instance and then touching all the other files and then get it, to me it feels like I get a little bit lost. And so we talked about we're going to kind of type this out as if the other stuff exists, and then we'll use this as our checklist for completing the other pieces.
Yeah, and I like that. I like that. It's very test-driven development-ish, right?
Mm-hmm.
So nice. Well, the first thing that we're going to start with is count. So this is something this is part of that Raft protocol, but when you set up your console servers, you need to be able to have a quorum, and a quorum just means a majority. They need to vote. So obviously 2 is not going to work because they can both say we're the leader. 1 will work, but you get absolutely no resilience there. So generally you want to start with 3. So that's probably we're going to go there. But in general, if you just pick an odd number, you'll probably be okay. If you don't want to do the n divided by 2 plus 1 thing, then we just have a chart under the console docs that'll just show you whatever it needs. So there's that thing. Next thing just is the Amazon machine image, and we can probably just straight up copy the one we're using for the database, because I mean, same database, same OS and everything. So that's probably good there. And while you're at it, if you want to grab that instance type too, we may as well, right?
We're going to use a, yeah, okay. Oh.
Nice. And then as for the subnet ID, so where we're going to launch these into, this is going to be very similar to what we have for the database, except we're going to use that count index to put it in a different one. Yeah. So as it iterates through, it's just going to put it in a different private subnet. Okay. And so then we've got 2 more fields here. So one is associate the public IP address, which we don't want them to have a public IP address. And then the key name, and this is going to be just to SSH into the servers. I don't know that we'll need to do that today, but in general, you're probably going to need to dive in and debug these at some point. There's obviously EC2 Connect and HashiCorp Boundary. There's a lot of different ways that you can do it, but just for simplicity, we're going to have that there. So the next thing is going to be the security groups. because that is where we're going to have to deal with all the ports, and that's probably where we'll spend a nice chunk of time there. And for this, it's just going to be a list, and we just the security group resource, and then as for the name, that looks good.
And that doesn't exist yet, so that's one of those things that we'll come back and implement that.
Yep. And then why don't we do that? We do have one more thing to put in here, and it's going to be another little Terraform technique we'll look at, and that's just for the private IP. Yeah, do you want to wait on that till after we do the security groups?
Yeah, let's go do that. Or
yeah, cool.
Should we?
So let's go ahead and go ahead.
I was just going to say, should we start with the Consul server count?
That sounds perfect. Let's go do that. So this is going to be really simple.
In the variables file.
Yep, in the variables file, wherever you think that it's good. And in the meantime, as you type that out, I've just got some questions here. Can you guys tell us more about building out protocols on a session? By building out protocols, do you mean just like the information around Raft and Gossip and just diving deep? If you could follow up, I'm more than happy to answer. And then is the service mesh that gets created the same for EKS as well? You'll probably have to elaborate on that for me as well, Moto, because I'm not really sure. You can certainly use Consul on EKS, but just clarify if you can. And congrats, Het Tanis, on getting the Terraform cert, and good luck with the Vault.
Awesome.
Yeah. Whoops. I've realized I've left that banner up for the GitHub repo like the whole time. Okay. Looks like we've got our variable done, which is great.
Set it to 3. In this case, we want 2 + 1. Is that what I understood?
That looks good. As long as it's an odd number, we're good.
Okay.
Now I will give just sort of a little warning here. If you're experimenting with this on your own, there is no penalty to scaling up, so increasing. But if you decide to decrement that value, you kind of got to be a little careful, because if the leader is the one that gets out, you're going to have some problems. So just be careful as you're scaling down. And we can talk more about that at a different time. But okay, so that takes us over to the security group IDs. So that is going to be next. And I guess we can go ahead and start this process up. So as she codes the base security group here, when we showed that chart, there's a good number of security group ports. And why don't we'll let you get the base resource set up before we dive into those.
Sure.
Yeah.
We're probably going to do a bunch of copying and pasting, but I'll type this first one out.
Yeah, that sounds good. That's what we would do if we were really doing it, right?
Yeah, exactly.
Yeah.
I'm going to copy that. And I feel like our tags,
we use a different
name.
tag. Yeah, they're just the default tags there. Yeah, there you go.
Okay, it's that project. Yep. There we go.
And for those of y'all, I think you need to remove the AWS _ right there at the beginning as well.
Yeah,
there you go. Yep. And if anyone has any questions or comments, thoughts on Service Mesh or anything we're doing, please throw them in the chat, and we're more than happy to take small detours and discuss them. So right now we're just making that base security group from which we're going to attach all of our rules to. So now that we're there, what do you say? You want to go back to the chart and we can just take a look at some of the things we need?
Sure.
Okay, cool. All right. So there are a number of different ports that you need opened here. And here's the thing is with our traffic here, we've got a number of different types of traffic going on. We have traffic over 8,300, and this is RPC traffic. So remote procedural call. And this is going to be for Consul servers, and this is going to be for data replication between the servers. Because I know we've been talking, what about gossip? We'll get to that. We actually use a different protocol to do the data replication between servers. And for Consul clients, it's what's used to request data from the server. So you can kind of think of it like the heavy port, right? We need to send really big information down a channel. Like this is going to be the port that we use. 8301, this is going to be for the gossip. So this is the lighter port, and this is going to be used by both the clients and the servers to figure out who everyone is, everyone who's a member of this cluster, detecting failures and event broadcasting across the cluster as well. So keeping those separate, you can kind of see how that creates less overlap and is going to create a bit more freedom in terms of these components talking to each other. Now 8302, this is going to be for wide area network, so WAN gossip, and this is just basically if you have multiple data centers, how the servers across the data centers can talk to each other. That's really it. Now, the thing to know is that if you do have multiple data centers, each of them will have their own leader. And so if you go from, say, data center 2 to make a request to data center 1, it'll go from leader in data center 2 to leader in data center 1, who will then handle the request for them. Now, the other ports that we don't see on here that we're going to have to open up are 8500, which is going to be for the literal Consul API that we will interact with, that the services will interact with. And yeah, so that's the HTTP API. There is 8501, which is just for HTTPS. And then there's another unlisted one here, and that's 8600, and that's going to be for the Consul's DNS server. So huge shout out to Blake Covarrubias. I don't know if he's on the stream, but he really helped me clarify all those ports because I had a lot of questions on them. So, and if it doesn't make sense, it probably make a little bit more here as we subject Jenna to more coding. So, yeah, we're going to focus on 3 rules though: 8300, 8301, and 8302. I believe. Hopefully that sounds right.
Yeah.
And
I'm gonna start writing it out.
Yeah, go for it. In the meantime, we had a question about hiring, just hiring, and I'm sure that I can't speak for AWS, but I'm sure that do y'all hire interns?
I know that there are some intern programs. I don't have the information offhand right now, but I do know if you go to the Amazon.jobs URL, that there'll be like actual job postings there. I'm not certain if internships are incorporated in there, but I bet Darko, who is out there in our chat, can maybe help direct you to the right. There we go. He's got the link that he's going to help share with us.
Darko. And HashiCorp.com/jobs, you'll be able to find the same thing for HashiCorp. Yeah. So there are a lot of security group rules that we're going to have to put together here. And this is one of those things where when you go to start debugging things, my advice here is to begin here. Begin here before you start looking at configurations and all the other little things. It's just my debugging tip is this: if I Google it and I see no one else in the world has ever had this problem or asked it, that probably means it's me. It probably means it's something I did. So there, I guess there's that little debugging tip as well. So, and in I did get a question specific to Consul. So if we have 5 Consul instances in a data center and 5 in another data center, do we need to open the gossip ports for all of them, as we don't know who the leader is going to be? So you will need the gossip ports open on all of them. However, they won't be gossiping, to my understanding, between data centers. They'll still be interacting with each other through the leaders. And as for the leader, there will be a leader in each data center. So they will go through each other and speak to each other through the wide area network. The wide area network gossip, which funny enough, even though we won't be using directly here, we will be, it's still required, because even when there's just one data center, the servers are still going to act like there's multiple and check in with each other. So hopefully that answers your question, Sorens. And if anyone in HashiCorp is in with me, feel free to correct me at any time. All right.
I added the 8300 and now I'm adding the 8301.
Nice, nice. And that's for the LAN gossip. Should be good. And as far as sure, but the given leader can change. Oh, so the follow-up question here. The given leader can change, it needs to gossip. No. So in general, maybe you can elaborate, Sorens, but as far as the leader going, whether this answer is fair or not, they all need to be able to gossip no matter what. So I don't know if that makes sense. Like regardless of the leader changing, the not leader changing, regardless of it being a client or a server, they all need to be able to gossip because that's how information is spread throughout the entire cluster. So hopefully that answers it. Yes. So ports here, and then I think, yeah, and just a nice little interesting thing I see Jenna doing here is the self equals true. That's just how you can set. That's just saying that like if another server has this security group, also do it or also allow it. You could also use source security group ID and just put the security group as well, but this is just a nice little convenience shortcut. Nice. Now, as for those rest of those ports, you may be wondering, well, when are we going to add all the other ones? We will do that when we get to the other part. But for the servers, just for them to communicate with each other, this is actually all we need for now. And hello, Anthony from France. Thanks for joining us. And here's our usual one, which is allowing any outbound communication.
Okay.
Yay.
We've got, yeah, so I think we're close here. We've got a rule for the inbound on 8300, the inbound on 8301.
Nice.
The LAN gossip protocol traffic. And then the WAN gossip traffic, which is the across data center stuff, is on 8302. Yep. And then finally is the outbound, which again, we haven't really done much there. We're just setting it up. Yeah. Nice. Looks like art. Love it. Beautiful. Okay. So go ahead. Do you have Nope. Go. I'm good. Oh, okay. So that finishes up the security group rules. So I guess let's hop back over to the EC2 instance. And now we need to specify the private IP of each server. This is gonna be a bit odd because I know what my impression was here, and that is to use an AutoScaling group, right? That's what I want to do. For Terraform, though, and for Consul specifically, it's going to be a bit better from an automation perspective and probably a bit safer from a scaling perspective to make individual instances. So there's two parts of this. For the scale up and down thing, you're going to want to pin these servers more often than not. They can handle a lot of traffic. You can get away with a ton of nodes. I don't know the exact numbers. It's a lot for just 3 servers, depending upon the size you make them. It's even more for 5, even more for 7. So you're not going to be doing something with the Consul servers where they're going up and down constantly. That's going to be more something you're going to put on the actual clients scaling up and down. So that's the first part. The second part is we need to know the private IP addresses up front to create TLS certificates that everything is going to need, because when we create a TLS certificate, we need to specify the DNS for which that certificate is for. So that's why we need to know that up front. That was a long way to say right now we just need to type private IP out. Okay. Yeah. And this is a new thing that we haven't done before. The The new thing is this local
Mm-hmm. So the
syntax
concept
here.
of locals. So when I first got into Terraform, I learned about variables, and I thought variables were like how they were in programming, right? Like I just use them to set values, evaluate expressions, and reuse them throughout the code. When you get into Terraform, though, variables are very much like a straight analogy to CloudFormation parameters. They're actually how you pass values into your Terraform project to be used. Locals, on the other hand, are how you calculate values within your project to be reused. So what we're going to do here real quick, and just for time, we're probably just going to paste this in. We're going to make, yeah, there we go, new file called locals. And I think Jenna's going to throw some stuff in here. Yeah, there we go.
Cheating. I'm doing a little bit of cheating here.
It's not
So I did
cheating.
some copying. Copy pasting.
Yeah. So with locals here, first let me tell you what we're doing, and then I'll explain what's going on. What we're doing here is we are taking the VPC CIDR variable that we can see on line 2 somewhere over on the right there, the var.vpc CIDR, and the public subnet counts and private subnet counts that we've specified, and we're calculating all of the CIDR blocks that we need for both our VPCs and just for other areas that we're going to use CIDR blocks. And then after we've done that on that line 4, we are calculating and deciding on specific private IP addresses. So the goal of this is to make it so that you coming to use this project, whoever you might be, you can just specify the VPC CIDR blocks, so the top level one, how many subnets you want for public and private, and be done. That is the whole point of this. And that's one of my favorite things about infrastructure as code is you get this extra automation that otherwise we would be doing by hand. Mm-hmm. Now, to make usage of this, and when we talked about it, Jenna, I think we decided to kind of not dive deep into expressions because we can see a for loop there. But that's just doing what it says, right? That in a nutshell, that's just saying go through all of our subnet counts and make some CIDR blocks, and then go through all of our private CIDR blocks and make some just, private IPs. So nothing crazy there. But now we need to go and make use of these, right? So why don't we go ahead and replace these out in our VPC just so we can show how those are used? What do you say?
So we're going to go into the VPC into here, and I need to have probably these. I'm just going to copy them.
Yeah, there we go.
And I'm going to, okay, let's get to the top here.
Yep.
We're going to do it in all of these places.
Yeah, just on line 18, we're going to replace that with local dot that value that you copied. Yep. And then just do the count index.
Right.
And we're going to leave IPv6 as it is. And the reason being is that we, with IPv6 on Amazon VPCs, they give us a block. We can't like specify our own. So we do need to get that here first. But that's a simple fix there. And that's a nice convenient thing. And then we just need to do it one more time on the private one. Yep, right there. Nice. Yep, that looks good. And then we don't even have to change anything in EC2 at all because we actually already are using it before we made it, right?
Right,
so,
right.
Yeah. But so, Jenna, when we talked about it, you had a really good question about locals, which was just kind of like when to use one, when to use a variable, right? Because you can do a lot with variables that you can do with locals. The rule of thumb really for me is that if you from, for example, the command line interface, from another Terraform project, from your CI/CD pipeline, need to pass a value into your project, use a variable. However, if you just have something you want to reuse throughout your project, but outside world doesn't matter, then use a local. That's probably the best way to look at it.
Yeah.
Okay. So that takes us into our next section, but we do have some questions. One with, I see Jeffrey here. You can just hit me up on just hit me up on LinkedIn, and Jenna, I'll let you answer for yourself there.
LinkedIn or Twitter, and we can answer questions that if it can't be answered here on the stream.
Yeah. And then just there is a really, really good question here, and that is, does it make sense to have a service mesh outside an orchestrator like Kubernetes these days? I think it makes, this is just me, I think it almost makes more sense in the sense that in a greenfield project and something where you can start with Kubernetes, everything is on containers, and you've got this nice, beautiful constructed stage of everything you want. But the reality is that your company or your team or whatever may have legacy infrastructure, right? Up on, maybe it's on-prem, maybe it's on a different data center, maybe some are in VMs, maybe some are in containers, blah, 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 right? The truth of the matter, the beauty of Consul is that it extends beyond an orchestrator like Kubernetes. It is something that we're going to see right here. We're going to see us stand this up and connect EC2 instances, so VMs, with our Fargate containers on one service mesh. And so that's going to be really neat. So I do think it does make sense. Do you have any thoughts on that, Jenna?
Not at the moment.
Okay, cool. Back to code we go. Okay, so Jeffrey, just hit me up over LinkedIn, and I can hit you up with an email. There you go. Cool. So that takes us, where are we next? For the IM role, right? So that is the next area here. So these servers, they need a way to talk to each other. And without some AWS magic, we're going to have to hard code IPs, which really isn't that bad because we've got those. But there's a nice feature that we can use, both where Consul and AWS come together to make it so that they can just auto-discover each other. But to do that, we need an IAM role for our instances that will allow for some of those permissions. So let's go ahead and add that IAM instances profile thingy here to our EC2 instance.
We're doing that in, we are doing that in here.
Yep. Yeah, nice.
Oops, that's not what I wanted.
Yes, yeah. Sometimes you win, sometimes it gives you the wrong thing. Nice. Cool. So now we get to go and make that.
And we are creating a whole new file for this, right?
Yeah. Let's just create a whole new file and just call it. Yeah, there we go. That's good. That works. Now, in terms of time spent on this, IAM, we could literally just turn the entire series towards IAM because there's so much in it, isn't there?
Yeah. Which means I'm going to do some copying and pasting, and we can
yes,
highlight some important areas here.
Yeah. And it's pretty straightforward. If you're doing this in Consul, this would be the easiest IAM role you would make. But it's just, of course, looking at it in the code, it can be a little bit funky. But Jenna, do you want to cover what we've done there?
Yeah. So we are essentially what we're doing is allowing the and correct me if I'm wrong here because this is a little bit new to me as well. Is we are allowing the EC2 instance that we've created for our Consul service to assume a specific role so that it can do different things in order to have this communication happen. So I've created the role, our actual trust policy, which allows the service to assume the role. And then we're creating the permissions policy that allows us to describe the instances.
Yeah. And I think the rest down there is just glue.
Yep, the glue code, yep.
Yeah, it just attaches everything to that umbrella resource at the top. Cool. So not too much there. Again, Jenna's got a survey. If IAM is something you want to see more of, perhaps just throw that in there and we can.
This is a good time for a break.
So
let me talk about the survey really quick. So, can you also put the link up on the screen?
Oh yes, good idea.
Because we know that not everyone wants to click a QR code, and that's cool. We also have a link. So this survey is, we want feedback to put into this show for future episodes or for future shows as well. We've been doing this. This is our 4th episode, and every single time we get survey results, we take that information and we help shape the next episode. And so your feedback is very much welcome to make sure that we are getting you quality information about AWS and HashiCorp technologies, but then also making sure that we're talking about the problems that you're having, that we are making sure we're getting your questions answered, that sort of thing. As part of that, there's an open-ended text field in there for the feedback. Again, it can be feedback about the show, but we also welcome feedback about the products and services that we're both building, because we have mechanisms to actually bring that back to our service teams and help shape what we're actually building as well, not just what we're doing here on the show. So the first 20 of you, I've said this in the past, the first 20 of you to fill out this survey will get an AWS credit code. Just beware that if you've filled out this survey for this show in the past, you won't be able to get the credit code. But we still very much appreciate your feedback, and we appreciate you hanging out with us. Either way.
Absolutely. I'll leave the survey link up for a little bit as we go. And I did want to highlight comment from Marshala. I believe I'm answering correctly. That's wonderful.
Yeah.
I hope that venture goes incredibly, because that's some really great work, and it's awesome. Tools are tools, but what they do for people, I mean, that's why we're in it, right?
Yep. Yeah.
Okay, so back into the fray, and that fray being pretty much stuff we've seen before, right? Like this is, and at least for this episode, where this is probably, we've gotten through most of the hard stuff. So I guess let's head back over to that EC2 instance and just add some simple stuff, right? So we've got some tags and like
oh yeah, we need the tags.
Yeah, some tags, and then what else we got? Like the placeholder for the user data, and then something else.
It depends on block, which I think we introduced that during our last episode.
I think we did, didn't we? Yeah, we did. We talked about it in the VPCs. Yeah. Jenna went and actually added one to the database in between episodes, just because there was a race condition whereby the EC2 instances would come up faster than the NAT gateway, and they wouldn't be able to talk to the wider internet, and they would cry and not work. So nice.
Okay. What am I missing here? I think I have it all.
That looks good.
For the tags, before we get to the user data, I'll just do the depends on.
Nice. I'm going to hide that banner that's covering up your code.
Oh yeah, please do. I can also adjust as well. Depends on, and then we're
Yep.
And like Cole just said, before we started today, I added this to our database. It's essentially the same thing, to fix that issue. So you'll see that when I push the code up to GitHub, you'll see that change as well today.
Nice. Yeah, make sure you follow along. Setup's really fast and easy on that project. So
yeah,
go ahead.
And then last but not least, I'm going to add in the user data piece here. And yeah.
Yep.
And I think this was a concept we introduced this last episode as well.
Yep. And just because of the length of the episode, we did have to choose, what we were going to do. So there's not a lot new today, right? Like we did still see like obviously the concepts, the whole big conceptual overview. So that's huge. But yeah, we're going to have to do, because the next part, we got a lot of stuff we got to make. So yeah. But for the next two things, so the instances here, the instances are actually pretty well done. We have two more things we wanted to do, hopefully in this episode, which will probably largely be copy paste, because if you've been following along with us, you've seen it. And that is just a load balancer that's going to be required for our Consul servers, and then the security group. So that's all that's going to be there.
Okay.
So
Go to load
yeah,
balancers.
let's head over to there. And then we can just drop in that next load balancer and then probably just talk about the differences, I guess.
Okay.
Unless you would like to
show
us your words per minute.
No. I mean, no. I don't need to see how fast I type. Because you're already experiencing it. So we've got a load balancer resource. And again, this is for the admins to connect to the UI. And when you say admin, do you mean like someone like me who wants to see the console UI, right?
Yeah, dead on.
Okay. Are there any pieces here that we want to highlight that are maybe different from what we've done in the past?
Yeah. So if we scroll down to the targets, so a little bit further, we are changing the target type to instance instead of IP, as it's been for the other ones, which is up some. It's under the target group resource.
Target group.
Yeah, right there. Okay, so line 157 is one of the differences. So that's one of the differences there. And then the second difference is the health check. We're actually hitting an actual console endpoint, just checking the status of the leader, which is a good solid way to see if everything is up and good. And then the port is, we're forwarding to the port 8500 as opposed to 80 or any other ones, because that's the Consul API. And then the new thing here is that target group attachment. When you use the target type instance, you need to add this extra resource, and it serves as the glue that connects each instance that you have to the target group of the load balancer. Okay. But this does leave us with the need for a security group, a new security group for the application load balancer. And we'll also kind of see a new concept related to security here as we create that. Which is just, it kind of goes back to your question, Jenna, which is, what is this load balancer used for? It's going to be used for two things. It's going to be used for one, for the operator to access, and two, for anything else within our VPC that needs to access the API as well. We can talk about some of the architecture stuff if we have more time, but that's in a nutshell what it's going to be used for. So, okay. On to security groups. Yes, this file is very long. If you have any ideas or preferences around refactoring or splitting them into different files, I am all more than happy to take that detour later. Okay, so this security group is pretty short, right? It's pretty fast.
I'm not typing it though.
yeah. There's no point. We've seen it before. Like we've seen it very similar. Yeah.
So,
and this is just, go ahead.
I just was going to say, and I've lost that file. We were in the load balancers. So we're setting our security groups here on line 142 to be this Consul server security group. And let's get back there. So that's what we're creating. Oops, we're going to have some of these that I probably have to fix more of, but I'm noticing this one.
Nice.
And then we've got our two rules. I have to sneeze, so one moment.
Good luck.
Okay, maybe not. A couple of our security group rules, inbound and outbound rules.
Yep. So all it's doing is just saying allow traffic on port 80 from largely anywhere, right?
Yep.
Yeah.
Yep.
Which I think we were going to, we can always change that around later. Let's see where we get to with this. There is one more rule we need to do though, right? And that is to allow traffic in from the load balancer to the Consul server security group.
And so this, from the Consul server into, what did you say?
So we need to allow traffic from the application load balancer into the Consul server.
Okay.
So
I wanted to make
that
sure I was
rule,
grabbing the right code.
Yeah, that's exactly it. I tend to group those with the group itself. So, but we can also leave it there. I'm not really sure what the better pattern is because this is directly affected with it. So it also makes sense to be there as well. It's just kind of up to you.
Do you mean up in this section up here?
Yeah, just with wherever we. Oh, okay, cool.
Yep, I agree with that. I think that makes sense.
Nice. Okay. Nice. Now there was one more thing, although we can potentially do that for later. We do have 11 minutes, and that was locking this security group down to just the operator's IP and then also just to the VPC itself. Do you want to knock that out now? I think that would be the last thing. Okay, cool. So let me, I neglected to keep that handy. So let me get that handy here. Apologies.
That's okay.
Okay, so the first thing, let me just send this to you because this will be a lot faster than me trying to explain it here. There we go. I just slacked it to you.
Yep, and we're adding a couple of variables.
Some variables. And we're just going to, what we're going to do is we're going to set some variables that allow us to control what CIDR blocks are allowed to access the Consul servers, specifically the Consul servers application load balancer here. Now, by default, they're going to be from everywhere and anywhere. Curious, did you make that Terraform? Okay, nice.
Already got that created. So yeah, so what he was asking was, have I created a variable in my TF-vars file with my IP address?
Yeah.
I've already done that.
That'll be, go ahead.
I've already done that, is what I'm saying.
Nice. And that will just override what we've got there.
Okay. So I don't need
After
to change
doing
that here, is what you're saying.
Nope. Yeah, that looks perfect. And I'm going to send you one more thing here. And this is just the updates we need to make to the application load balancers allow 80 rule. And it's just that CIDR blocks one. Oh, yeah, just into the security groups one.
In this, oh, wait. Oh, security groups. I was in the right, I was going to the right spot.
Yeah. All good. I mean, there's so many files. It just happens.
So we're doing that here.
Yep. Dead on. And then I believe we should probably just get rid of that rule altogether there, right? Because
this one here.
Yeah, I mean, you can put that there, but I don't think you had a IPv6. Right. So we can also just leave that blank. And if we leave that blank, no one will be able to access it on IPv6, which probably what we should do is probably just get rid of it. That was, So just delete line 305.
Got it.
Yeah, there we go. Nice. So what that's doing is it is allowing two blocks, right? It's going to allow both the block that Jenna has specified in the background that controls to her IP address, but it's also going to allow any traffic in from the VPC itself. So it's just a nice little trick there to make sure that that's locked down. So, okay, that then I believe brings us to our breaking point for today. I mean, there's some other stuff that we can set up around like the bastion and the like, but we can probably just do that in the background, right? Or perhaps in the next episode. But yeah, so what do you think so far? We didn't get to touch a lot of new specific Consul stuff, but
yeah, I think there's a lot to this, and I'm glad that we're breaking it up because I think I don't know about all of you at home, but like this will be good for me to kind of sit on what we've done so far because we learned a lot about like service meshes in general, and then we layered on top of that console and that architecture, and then we started implementing it. And so there's some layers that we need to kind of absorb.
Yeah, there are. And I've got a couple of links I'm going to post into the chat. And that way we can, and I'll put that banner up for the survey. Please help us out. You know, if you want to see something different, or even if you just liked something, you know, we would love to
Yeah,
hear it.
we like
But
hearing that too, because then we know to keep doing it if you like something.
yeah, absolutely.
Yeah, again, that survey, that's really so that we can make sure we're helping you in the best way and building you the products and services the way that um that you need to solve your business problems. So um that is appreciated. You were looking for something else, I think. Oh yeah, here you're pasting in some of the we've got some links that Cole is sharing in the chat
Mhm.
related to the console architecture, um, the raft concept,
Mhm.
um,
Yeah.
gossip protocol, all that kind of fun stuff.
Mhm. I'm having to post them separately in LinkedIn,
Yeah,
so
yeah,
they're
yeah.
showing up a little delayed. Are there any other links that I needed to drop in there? I mean, I think
Is there?
probably this
Yeah,
big,
I think
probably
those
this
are
big
kind of the big
one.
ones. I know we've shared the code a couple different times now. Um, the survey you have, uh,
Mhm.
yeah.
Nice,
Oh, I
nice.
have something I want to share with you, with all of you. So um, this, I'm going to drop a link into the chat. This is where we're starting, at AWS, we're starting to uh, share our events that different developer advocates are doing, whether that's AWS events, whether it is events with some of our partners or at external conferences and meetups. And so this is essentially a calendar that you can go and look at. So I'll drop that in. I don't have the next episode up there yet, but we'll get that added probably Friday-ish before Monday
Nice.
is kind of my plan. Um, and then that way you've got some place to come and look to see when we're doing stuff again. Because I know that's been a little not consistent for us. And so we're trying to improve our processes here as we get going a little bit further.
And your survey will help that even more.
Exactly. Yeah. That this is direct feedback from our survey is like, how can I find out
Yeah.
about more events? This is where you can find out about more events. So yes.
Nice, nice, nice. And hey, we actually time boxed it to an hour and a half.
This is great. I again like we appreciate feedback on like the timing of this too and how we're breaking it up because we've struggled with it every episode we've talked about it before and after the episode trying to figure out what's the what's the best way to do this. So again, your feedback has been very helpful there and will continue to be.
Yep, yep. Well, so
So I
go
just going
ahead.
to say one thing we haven't done is a Terraform apply. And I
Ah,
assume we can't do that yet, right?
I would probably leave it.
Okay.
It's
Yeah. And
just,
that's
yeah.
that's fine. And a big piece of that is because of this section in our EC2
Mhm.
instances that we've created, we still have this left to do. So I just wanted to
Yeah.
call that out that for the people at home so that you understand why we're pausing. We're not gonna, implement this quite yet or apply it
Mhm.
yet. Um,
Yep.
because we have at the end of every show in the past.
Yeah.
But
And Go ahead.
I was going to say, but what I'll do right after this is I will commit all my changes and push those up to GitHub so that you have access to the code that we wrote today.
And I'm going to put that link for the code up one more time
Yep.
there.
Yep.
Just so you've got it. Yeah. So just, I guess a concept, quick recap, right? We just set up the Consul servers, their security groups, IAM role, and that was pretty much it in a nutshell. Yeah. I think so.
I think so. Yeah.
Now, for those of you being like, oh gosh, this is so much work. It is. It's one of those things. Service Mesh has a lot of upfront investment, right? It's kind of like the concept, but you got to think about it like the concept of like fixed costs with like the factory, right? Like you build a whole factory to make one book, you're not really getting your money's worth. But when you're making thousands of books, right? That's when the factory starts paying for itself. So we've got some more work to do. Funny enough, like the second part of this is even more than what we did here. So, but it'll be fun, right? We'll see some TLS stuff. We'll dive into the config files, which will be fun. And start learning more about the innards of Consul, which should be entertaining, for lack of a better word. Yeah.
Yes.
Right. Well, anything else? Any other final thoughts, Jenna?
I don't think so. I think we're at a good stopping point. Again, survey feedback is very much welcome. If you have other questions, feel free to reach out to either of us on Twitter or LinkedIn is probably the best place for that.
Yep.
And yeah, this has been fun.
Yeah. Thank you, everyone, for joining us. We've got a lot more fun stuff to tinker with next time. We appreciate everyone who's given us feedback. And I think our next one will be tentatively planned for the 28th, right?
I think that's the plan. Yep.
Okay.
All righty.
Well, until next time.
Yes. Bye-bye.